Hey Global Impact, this is Mr. Ellinger. This lesson is on the distributive property. Our learning target for the unit is to be able to use the distributive properties to simplify expressions. Our learning target is use the distributive property to simplify expressions. Essential understanding for the lesson: the distributive property can be used to simplify the product of a number and a sum or difference. An algebraic expression can be simplified by combining the parts of the expression that are alike. Background for the lesson: unlike other properties of real numbers, the distributive property combines multiplication and addition. The distributive property is A times the quantity B plus C equals AB plus AC. Also, A times the quantity B minus C equals AB minus AC. Multiplication is commutative, so the order of the factors can be reversed and the result will be unchanged. If we take the quantity B plus C times A, that's going to equal AB plus AC. And if we take the quantity B minus C times A, we get AB minus AC. The distributive property will allow you to find the product of an algebraic expression and a number. Later in algebra, you will use the distributive property to find the product of two algebraic expressions as well as to factor some algebraic expressions. Okay, so what is the distributive property? Well, whenever you use the distributive property, you should think distribute. Well, what does distribute mean? Distribute means to like pass out or hand out. So when we talk about the distributive property, I think it's a good idea to always remember the concept of distributing. Okay, so we have four examples here. Okay, four generalities, and then we have four specific examples. So I'll just talk about the first one here. A times the quantity B plus C. Okay, so if we have some value times a quantity in parentheses, and that quantity is a sum, then we distribute the A to B and C, so we get AB plus AC. And then this one here, A times the quantity B minus C, we have two things and a difference in the parentheses. So we have to distribute or pass out the A to both B and C. A times B is AB. We have a minus sign, so we'll have a minus sign here. And then A times C is AC. And again, you can see specific examples over here. All right, so let's just do some of these examples. I'm going to write out these examples to show you the steps. Here we have the quantity 5 times x plus 7. The distributive property tells me that I'm going to take 5 times x plus 5 times 7. 5 times x is 5x. 5 times 7 is 35. I've got an addition sign here, so I'm going to add 35. Okay. Second example, we've got a 12 in front of the parentheses, so we're going to take 12 and multiply it by this quantity. In the quantity, we have 3 minus 1/6 t. So let's pass out 12 or distribute 12. 12 times 3. We have a subtraction sign here, so we'll transfer that over here. We're going to take 12 and multiply it by 1/6 t. 12 times 3 is 36. We've got a subtraction sign. 12 times 1/6, that's what we can actually multiply. Remember the associative property of multiplication. 12 times 1/6 is 2. And we have t here. So 36 minus 2t is what we get when we distribute 12 to this quantity. All right, last example here. This isn't very common. Here we have a quantity, a difference, and then after that quantity we have a number, -7. The number that we're going to distribute or pass out is actually after the quantity. Again, it's not common, but we still need to understand that this is a distributive property problem. One thing that we can do, we have one set of parentheses multiplied by another set of parentheses. If you remember, we can multiply things in any order that we like. So we can reverse the order of the multiplication and write it this way, which I believe makes more logical sense in terms of the distributive property. We're going to take -7, we're going to distribute it to 5b, and we're going to take -7 and distribute it to 4. Okay, so here's what that looks like. -7 times 5b. There's a subtraction sign in here. -7 and 4. Okay, We have to be a little careful with our signs here. When we're distributing negative signs and we have subtraction in here, we have to be a little careful. So I suggest doing it the way that I've just done it here. Negative 7 times 5b is negative 35b. I have a subtraction sign. Negative 7 times 4 is negative 28. Remembering we can change subtraction to addition by adding the opposite of this. So negative 35b plus positive 28, or plus 28. Okay? One thing that I want to point out here is this two sign stuff here. It's not incorrect, but it's not simplified. In our answers, we want one sign. We have a negative sign in front of 35b. We have an addition sign, and we have a number 28. These are distributive property problems as well. Scary looking fractions here. The first one, we have the quantity 4x minus 16 over 3. But when we have this fraction bar, the fraction bar acts like a grouping symbol. So the way that we can think about this is really 4x minus 16, that quantity, divided by 3. And that's not that useful, but what we can do is we can say, all right, well, division by 3 is the same as multiplying by 1/3. So let's do that. We're going to distribute 1/3 to 4x minus 16. So the way that that happens is we can multiply 1/3 times 4, that's 4/3. X minus 16 times 1/3 is 16/3. So there's our answer. That's simplified. Using that same concept here, I'll bypass the divide by 3. This is the same as taking this quantity and multiplying it by 1/8. So I'll take 1/8 and I'm going to write it in front of the quantity this time, which is okay. All right, so that's how I would change this problem. All right, going from here to here. And then I just distribute the 1/8. So 1/8 times 4 is 4/8. Minus 1/8 times 2 is 2/8 times x. Here we have some fractions that can be reduced. 4/8 is 1/2. 2/8 is 1/4. So there's our answer, simplified. Another example of the distributive property, and this is a key one. The multiplication property of -1 states that -1 times x is negative x. So anytime you see negative x, that's the same as -1 times x. To simplify an expression such as negative the quantity x plus 6, we can rewrite the expression as -1 times the quantity x plus 6. So that's how we handle a problem like this. A negative sign in front of this parentheses. By this rule, we just distribute the negative, or think of it as -1 times a plus 5. -1 times a is negative a plus -1 times 5. We have negative a. -1 times 5 is a negative 5. We're going to add a negative 5, but rather than putting plus minus 5, we don't want that. So we'll put minus 5. Another way to think of it is, if you see a negative sign in front of a set of parentheses, basically what you need to do is just change the sign of what's in the parentheses to distribute that negative. So we went from negative, and then the quantity, a plus 5, both positive, to a negative a minus 5. Another example, a negative in front of the quantity 4x minus 1 is the same as -1 times the quantity 4x minus 12. Distribute the -1, we get -4x plus 12. Now, rather than doing this step up here on this example, I want to address one other thing. Rather than saying, okay, -1 times positive 5 and writing it this way with the addition sign here, another way you can think of this is, write it down here. This is what we're doing. -1 times a is negative a. -1 times a 5, well, the plus sign in front of the 5, treat this 5 as a positive 5. -1 times a positive 5 is a negative 5, so we'll put a minus 5 here. It's a little shortcut that might come in handy if you like it as we move forward. Okay, the second part of this lesson, we're going to talk about expressions. More specifically, these are a preview of polynomials that will come in a later unit. In an algebraic expression, a term is a number, a variable, or the product of a number and a variable, or one or more variables. A constant is a term that has no variable, meaning just a number. A coefficient is a numerical factor of a term, meaning a number in front of a variable. We rewrite expressions as sums to identify these parts of an expression, meaning change all subtractions to addition. So here we have an expression 6a squared minus 5ab plus 3b minus 12. So the first thing to see what we did here, this is equivalent or equal to 6a squared plus negative 5ab plus 3b plus negative 12. And then from there, we can identify in these terms, the terms are 6a squared, negative 5ab, 3b, and negative 12. Those are the terms, because we have sums, plus, plus, plus. The coefficients of the variable terms are 6, negative 5, and 3. Numbers, again, the numbers in front of the variables. Sometimes we call them the big numbers. And then we have one term that doesn't have a variable in it, negative 12, so we call that a constant term. It's called a constant because if it doesn't have a variable attached to that term, the value of that term is always going to be negative 12, or it's going to constantly be negative 12, hence the term constant. All right, another vocabulary or a tool that we're going to use is identifying like terms in an expression. Like terms have the same variable factors. To identify like terms, compare the variable factors of the terms as shown below. So here we have two terms, 7a and negative 3a. The variable factors in those two terms are a and a, so they would be considered like terms. Here we have two other terms, 4x squared and 12x squared. They both have variable parts x squared and x squared, so they are like terms. Another example, we have 6ab and negative 2a, two terms. 6ab has variable factors ab, negative 2a has variable factor a, not like terms. This one has ab in it, this one has just a in it, so they're not like terms. Like terms have to have the same variables, and the exponents on those variables have to be the same as well, which kind of leads into our next example. Two terms, x y squared and x squared y. Well, the variable factors in the first term are x y squared, second term x squared y. So if you look, both have an x and a y in them. But the first term has y squared. The second term has x squared, so they are not like terms. Another aspect of this, combining like terms, we can use the distributive property to help combine like terms. Think of the distributive property as BA plus CA equals the quantity B plus C times A. It's kind of like the reverse order of the distributive property. We're going to start off with something like this and rewrite it as something that looks like this. The definition of the distributive property, we would always start with something that looks like this, and we would distribute the A to these two terms. Let me show you an example here real quick. 7x plus 3x is the same as 7 plus 3, that quantity, times x. And what that does is that gives us a key or a clue on how we're going to combine like terms. 7 plus 3 is 10x. So here's a worked out example of combining like terms. We have an expression 5x minus 3 minus 3x plus 6y plus 4. Okay, so the first thing that we want to do, and again, this is just a good habit to get into, rewrite the whole expression as sum. 5x plus negative 3 plus negative 3x plus 6y plus 4. We can use the commutative property of addition. That's why we change subtractions to addition, because we can start moving things around. Use the commutative property to put like terms next to each other. All right, we have our 2x terms, 5x plus negative 3x. We have our y term, and then we have our two constant terms next to each other. Then what we can do is use that quote-unquote backwards distributive property that we just looked at to take the 5 minus 3 and write that as a quantity times x. 6y we can't combine it with anything. Negative 3 and 4 we will. So 5 minus 3 is 2. So when 5x combines with negative 3x, we get 2x. 6y didn't combine with anything, so it remains 6y. Negative 3 plus 4 we know is 1. So this expression that we started with simplifies down to 2x plus 6y plus 1. Okay, and again, think about the word simplify. We have a lot of different contexts for simplify. Simplify could mean add things together, multiply, calculate whatever numerical calculations you can do. When we start looking at variable things and variable expressions, what we're going to do is simplify. Another way to think of simplify is shrink down, reduce it down, less terms. We started off with an expression that had 5 terms in it, and we wound up with an answer that had 3 terms in it. It's simpler. All right, here's 2 examples. 7y cubed z minus 6y z cubed plus y cubed z. First thing we want to do is rewrite this as a sum. So 7y cubed z, and I make my z's like this so they don't look like 2's, plus negative 6y z cubed plus y cubed z. The next step would be to use our commutative property of addition and kind of shuffle this around to put like terms next to each other. Our 2 like terms in this expression are these 2 right here. So we will move them next to each other. And we will slide this other term over here. And now that we have our like terms next to each other, 7y cubed z plus y cubed z, we're going to combine those 2. Well, how are we going to do that? We're going to use the distributive property. This term here, we need to always remember there's no number, there's no coefficient, but anytime you don't see a coefficient, there's an implied 1 there. So the way that we're going to simplify is we're going to take 7 plus 1, that quantity, and we're going to multiply it by y cubed z plus negative 6y z cubed. 7 plus 1 is 8, so we have 8y cubed z. And then we're going to change this plus minus back to a minus 6y z cubed. So there's our answer. That is what we call simplified. And one more example. Change our subtraction to an addition. The nice thing here, we only have 2 terms. Can we combine them? Well, if we look at our variable parts, we have mn to the 4th. Over here we have mn to the 4th, so the answer is yes. So we use our distributive property to take our coefficients. Negative 7 minus 5. That quantity times mn to the 4th. Negative 7 minus 5 is negative 12. So we wind up with negative 12 mn to the 4th. That's simplified. Combine 2 terms into 1. Hope you have a great day.